This is Chapter 3, Lecture number 2. We're on page 27 in the notes. A physical change is a change in a substance without changing its composition. For example, cutting. If you cut a piece of paper, it is still paper. You did not change its composition. Breaking. If you break glass, it is still glass. Melting. If you take ice and you melt it, it's still H2O. All you did was change its phase. All phase changes are physical changes. Freezing, boiling. The melting point is the temperature at which the phase changes from solid to liquid. So the melting point of ice is 0 degrees Celsius. That is an intensive property. The boiling point is the temperature at which there's a phase change from liquid to gas. A chemical change is the process that involves one or more substances changing into new substances. We will call this a chemical reaction. Examples: explode. These are the cool words in chemistry. Decompose. Corrode. We are forming new substances when these occur. Chemically, in an equation, we say reactants, that which reacts, will turn into products, that which is produced. During any chemical reaction, there is a law of conservation of mass. Mass is neither created nor destroyed. During a chemical reaction. It is one of our fundamental concepts of chemistry. So if we look at the data in the table below, it wants to know how many grams of bromine reacted. This is pretty straightforward. There's 100 grams of bromine before the reaction. There's 8.2 grams of bromine left after the reaction. So the amount of bromine that reacted is 91.8 grams. The next question is a little tougher. How many grams of compound were formed? We have to know how many grams of reactant react. So 10.3 grams of aluminum reacted, 91.8 grams of bromine reacted, for a total of 102.1 grams. If 102.1 grams reacted, then 102.1 grams of product have to form. Turn to page 31. Turn to page 31. Entropy is a measure of disorder in a system. As the disorder increases, the entropy increases. Entropy is a measure of disorder. So is there an increase or decrease in entropy in the following processes? As you go from solid to gas, you become more disorderly. The entropy will increase. As you go from gas to liquid, your randomness decreases, so your entropy will decrease. At this point, pause the video and go ahead and do the next 4 examples. Melting is solid to liquid. Your entropy will increase. Boiling is liquid to gas, so your entropy will increase. Burning produces smoke and ash, so your entropy will increase. Freezing is the liquid phase going to the solid phase, so your entropy will decrease. In terms of a chemical equation, we look at the symbols. Here we have a solid turning into a gas, even though it stays CO2. This is a process called sublimation, and your entropy is increasing. So it will increase. Here we are going from a gas in the gas to a liquid, so your entropy will decrease. And here we go from order to randomness, so the entropy will increase. And that is it for lecture 2. So have a great night.